What's up, you guys? Guess who? That's right, it's Miss Brothers. Just wanted to make a video that takes you through this dimensional analysis practice sheet, and just a quick reminder of the process of doing these as we start our molar mass conversions and our stoichiometric practices in the coming days. Then again, falling back on the processes that we have for dimensional analysis and specifically using our T-chart. That's what this practice is all about, and that's what I'm going to take you through for the next few minutes, okay? So for our first one, it says, how many meters are in 7.3 feet? Remember that 1 inch is equal to 2.54 centimeters. So again, you guys, when we're going through this process, that can be very daunting because, again, I'm asking you to use the T-chart method. The first thing we have to do in any case is to figure out what is it we have to end with. So what we have to end with is right here. How many meters? The unit that we must finish with has to be in meters. So whatever we do, when it's all said and done, that's the unit we have to end up with, okay? Then we can talk about what we have. We've been given this starting unit of 7.3 feet, and we have this fun hint over here that I'm sure will come in very handy later. Now remember, you guys, when we're setting up the first part of our T-chart, the first T, we always start with the unit that we are given to start with, and that is 7.3 feet. Now, if you remember, just for fun, a lot of times it's nice to be able to set this over 1 because then it makes this nice fraction ratio, which makes us very happy. Now, what we have to do is we have to go out and figure out what kind of relationship we have and what kind of hints that we have. So we have this hint that gives us a unit of 1 inch. So I'm going to ask myself this question. What kind of relationship do inches and feet have? Because remember, you guys, we have to be able to cross out this unit right here. We need to be able to cancel it out at some point because we don't want to end with feet. We want to end with meters. So we're going to start by saying to ourselves, all right, I know that there are 12 inches in 1 foot. So I'm going to put 1 foot down here because then I can cancel these two things out and I can put 12 inches right there. I'm going to go ahead and cancel my feet out right now because, again, you guys, I like to cancel my units as I go because it makes it less kind of confusing and convoluted as our T-chart grows over here to the right. So that's pretty good. Now, am I done yet? The answer is no, I'm not done yet because right now the unit I have left is inches and I have to end up in meters. So I'm going to add another to make another T-chart. So now I have to ask myself, do I have a relationship between inches and meters? And technically I really don't yet. What I have is a relationship between inches and centimeters. And according to this, 1 inch is equal to 2.54 centimeters. So I can set that up in my T-chart right here. I'm going to put 1 inch down here, and that's great. I'm going to do that because now I have the ability to cancel out this unit with my inch unit right here, and up on top I'm going to put 2.54 centimeters. Okay. I'm going to go ahead and cancel out my units now. Done. Bye. And that leaves me with a unit of centimeters. I'm not done yet because, as you recall, I'm trying to find meters. So now the question is, do I have a relationship between centimeters and meters? And if you think all the way back to middle school or all the way back to the beginning of the year, we know that there is a relationship between centimeters and meters. We know that 1 meter is the same as saying 100 centimeters. And again, I'm putting centimeters down here at the bottom and meters on the top because now I can cancel out centimeters. And what unit is left? Meters, which is the unit I have to end with. So now it's just a matter of doing the math. So what I do is I work from left to right across my T-chart. So let's see, I've got 7.3, and remember, I'm multiplying across. If I'm going up to down, I'm dividing, but since I'm going across, it's going to be 7.3 times 12 times 2.54, and I'm going to have that unit of meters right here, over, and it looks like I don't have to worry about those, but I have 100 over here. So now it's time to do some math. Let's do that. So I've got 7.3 times 12 times 2.54 equals, that's 225.504, but remember, I have to divide that by 100. Divided by 100 equals 2.22504. And again, my unit is meters, but I'm going to round this. I'm going to look and see what I have here. It looks like it makes sense to me to take this to the nearest tenth, so that's what I'm going to do. I'm going to go ahead and this equals 2.2 meters. Okay, and so again, 7.3 feet is the same as saying 2.2 meters, and I used my T-chart method in order to do that, going through and canceling my units as I go. All right? Okay, now let's go ahead and do this next one, and I'll just have to write small. How many minutes do I have in 1 year? So again, you guys, there's a lot of different ways you can do this, but again, what am I trying to figure out? I'm trying to figure out minutes. Okay, so let's start with that. I know I have to find minutes. What they give me is 1 year, so I'm going to go ahead and put that down. 1 year. I'm going to start my T-chart right there, and I'm going to set that over 1. Now, do I have a relationship between years and minutes? I don't know what that is, but what do I know? I do know that 1 year is the same as saying 365 days. So far, so good. Now, can I cancel some units? You sure can. I can cancel 1 year. I don't even have to worry about the 1. I'm just canceling it out. Now, the next thing is, do I have a relationship between days and minutes? I don't. I'm not that smart, but I do have information about minutes and hours. So what I'm going to do is I need to find a way to get rid of 1 days. That's the unit. And I know that there are 24 hours in 1 day. So now I can cancel out the unit of days, and I'm left with hours. Now I ask myself, is there a relationship between hours and minutes? And there is. I know that 1 hour is the same as saying 60 minutes. So now I can cancel out my unit of hours, and look, the unit I'm left with is minutes, which is the unit I'm trying to find. And now it just becomes a matter of doing the math. So I've got 365 times 24 times 60 minutes. So again, we can do that math. I've got 365 times 24 times 60 is 525,600 minutes. And that's my unit right there. And again, I'm going to go ahead and circle that. All right. So really what it comes down to is this, you guys. When you're doing these dimensional analysis problems, it's all about your process. What do you have? What do you know? What can you get to? Let's do another one. Let's do this next one. If you have 2,000 ounces of chocolate, how many kilograms of chocolate do you have? Well, let's kind of go through this, and again, let's figure out what we have. If you have 2,000 ounces of chocolate, well, we have ounces, so that's awesome. How many kilograms? We're trying to get to kilograms, okay? So what we're going to have to do is we might have to do a little bit of Googling here, but that's not a problem. We can totally Google. We know how to do it. All right, so let's start with what we have. We have 2,000 ounces, okay? So let's put that here, 2,000 ounces over 1, and let's go ahead and set up a T-chart. Now, do I have a relationship between ounces and kilograms? I do not, so I'm going to have to do a little bit of research here, okay? But I do have a relationship with pounds and ounces, or I could look up kilograms. Let's go with this one. Let's go 116 ounces is the same as saying 1 pound, okay? Let's do that. Now I can go ahead and get rid of that ounces. Now, let's see. Conversion factors. Set up a T-chart. And like I said, it looks like we can look some stuff up here. So let's go ahead. And I've established myself with pounds. Let's go, how many... I'm sorry, I'm looking this up using the Google right now. That's why you can't see what I'm doing here. Let's see. How many grams Ooh, in a pound. Let's do that. All right, so I've just figured out that 1 pound is the same as saying 454 grams. All right, so now, ooh, this is good. I can cancel out my pounds here. And now, do kilograms and grams have a relationship? They most certainly do. We know that 1,000 grams is the same as saying 1 kilogram. So now I can go through and I can do some math. Now for this one, I'm going to have to set this up. I got a lot of work to do here. I have the unit that I need because I've canceled out grams. So now I have to take 2,000 times 454, and we've got our unit of kilograms over here. And over that we have 16 times 1,000. All right, so we got a little bit of grinding out to do here, so let's do this. So let's take 2,000 times 454 equals 908,000 kilograms over 1,000. So now what we do is we're going to take this divided by this, divided by 1,000, equals 90.8 kilograms. Well, that doesn't seem right. Did I do that right? 2,000 ounces of chocolate, 98. Well, maybe it does. I'll have to check my work on this later. But you get the idea is that I'm going through a process, and all I'm really doing is I'm figuring out relationships as we go. What relates to what? If I've got ounces, where can that lead me? What do I know? I know that 1 pound is the same as saying 16 ounces. I know that 1 pound is the same as saying 554 grams. Oh, I know what I forgot to do, did I? No, I did that right. I know that 1,000 grams is the same as saying 1 kilogram. So it's just one of those things where you just keep going through until you finally get to the unit that you have to finish with. Okay? It can seem a little bit convoluted, but that's how we go through and do this process. Now, we have spent a little bit of time working on these. Let's go ahead and do one more of these before we head out. Let's go ahead and do number 7. Okay? How many days are in 4.52 times 10 to the 18 hours? This doesn't work any differently than any other type of dimensional analysis problem. We still go through, we figure out what we have to get to. We have to get to days. We figure out what unit we start with. We start with hours. And now it's just a matter of setting up our t-chart. So we have 4.52 times 10 to the 18th hours over 1. And let's go from there. Again, we're worrying about our units first. We'll get to this in just a second. So what kind of relationship do I have between hours and days? Well, I know that in 1 day, I have 24 hours. So this is going to be a fairly short t-chart because we are already to the unit we have to get to. So now it's just a matter of I'm going to cancel my units and I'm going to do my math. Now again, you guys, I have to use these functions on my calculator. If you're using this calculator right here, this is the 30XA, it's really straightforward. I'm going to go 4.52, and I have to get my exponent in there, so I'm going to hit the EE button, which is this button over the 7. I'm going to type in 18 because that is my exponent, 18. And I'm going to divide that by, I'm going to divide that by 24 hours. Divided by 24 equals, and it gives me this number right here, 1.88, and then lots of 3s, times 10 to the 17th. So that's what I'm going to write out right here. Now, as far as precision, it looks to me like I'm going to go to the nearest whole number here because that's as precise as I'm given right there. So I'm going to just round up to 2.0 days. Now, if I were rounding this to, like, say, the nearest 100th, that would be 1.88 days. And that's, well, yeah, sorry about that. I have to do my exponents here. 2.0 times 10 to the 17th days. That's better. Whew, had a little brain fart there for just a second, but I figured it out. All right, but so when it comes to doing a problem like this, you just have to use the functions on your calculator. And if you're using one of the XAs, which is my classroom calculator, it's pretty straightforward. If we do the same problem using one of these, it's a little bit less straightforward because we have to, we would put in our 4.52, but then we have to go to the second button, then go to the EE button, and we're going to divide that by 24 equals, oops, I did that wrong. So 4.52 second EE to the 18th divided by 24. There we go. And you end up getting that same thing. Oh, that didn't turn out like I wanted it to at all. What am I doing here? 4.52 second EE to the 18th divided by 24. That's better. There it is. Just typing away, making mistakes. That's okay. Cleaning it up. All right, but again, same thing. We're rounding that to 2. Like I said, you just have to do a little bit more in terms of plugging into your calculator, but that's how you do it. So there you go. Dimensional analysis. And again, you guys, I have this key posted online, so if you wanted to take a look at the key, you have that you have that access to you. And then if you want to know process, you can watch this video. All right, you guys.